Hello, we're Bravo 6, and this is our design review presentation for our bat and watch. I'm Andrew.
I'm Alex.
Hi, Michael.
And I'm Nate.
So the way we divided our group was having two different subgroups. Michael and Nate were in charge of circuit design and React app development, while Andrew and I were in charge of fabrication and assembly.
So this is our concept. So I was inspired by just a pirate with a parrot on their shoulder. So we decided to build a bird that would sit on one of our shoulders, and we decided to add a screen as well for data transmission and collection.
So here's a general timeline of our project development. I'll just quickly talk about some of the main points. So by the end of day one, we had the 3D printed. We had assembled the head and the body and got the Wi-Fi connections working between the sensors, back end, and the front end. By day two, we finished printing the watch parts. We added a servo to make the head turn, and we fully built out the front end and back end using the subscriptions. And finally, on day three, we finalized the full assembly of the bat, put all the circuits inside, and made sure the hardware and software were fully connected and working.
So I made the bat out of SolidWorks and 3D printed it, and it was comprised of several different components. I added this modularity for ease of access when installing the components. The main head held the camera, the head cap held the exposed pressure sensor and eventual light sensor, the body held the main circuit and ultrasonic sensor, and the wings supported the bat upright while in the holder. Um, so the shoulder mount was a hybrid structure combining 3D printed and textile elements. It was U-shaped to better wrap around the anatomy of the shoulder. However, this design proved to be too narrow, so I had to cut off the back end. Small holes were made in the bottom to allow for a rope to attach under the armpit to secure the mount vertically on the shoulder. Later revisions, I added a chest strap because we were running into this issue where the shoulder mount was falling off the shoulder due to the plastic, the slipperiness of the plastic. And then foam was attached to the inside for better user comfort.
So I designed the watch on Onshape and went through two iterations. The first one was bulky and unstable, and the cover failed during 3D printing. So in the second version, I made it much smaller and more discreet. And after settling with that version, I started the fabrication process. I 3D printed the casing, laser cut the base of the watch with acrylic, and I made finishing touches with the Dremels and power drills. The acrylic was much faster and less prone to failure. And we ran into a few challenges. One of them was that the 3D printing failed, so again, I used laser cutting. The watch band fabric at first was stretchy, so I used foam to make it more stable. And then lastly, the shoulder mount wasn't very stable either, so we used a chest and shoulder strap to support it.
Okay, so onto the electronics and the schematics. So the key components that we had to integrate were the Raspberry Pi, the 5-volt voltage regulator, a camera, a servo, a light sensor, a temperature and humidity sensor, a distance sensor, and an OLED display. And on the right, you can see how it's connected. So starting with the battery, we sent that into a voltage regulator, which then powered the camera, servo, and Raspberry Pi. And the Raspberry Pi was connected to the ultrasonic, OLED, temperature and humidity sensor, as well as the photoresistor. This is our main circuit diagram, but basically on the top part of the top half of this, we have the 5-volt circuits and the regulator, which powers it. And then we have the 3.3-volt line coming out of the Raspberry Pi Pico to power the remaining sensors on the bottom. As for how it communicated with our server or our backend, we have the Pico, which publishes information through the broker. And then this broker sends the information to the backend. And this is all done using MQTT. From there, we use Socket to push the data to the front end, and the data also went back as well as we use the buttons. this is our code. So this is the structure of our repository, and it included a few folders. Right now we have the CAD files and schematics in there as well, but I'll only be talking about the code. So starting with the AI, this was when we integrated the Chat GPT API, where um, we used the camera to take a photo, and in receive, it got the image and then it sent it to the send to OpenAI file, where we got a response from the OpenAI API that turned it into a MP3 file. For the backend, we use Node.js, and in index.js, we have all the protocols that were used to send data between the MQTT broker and the front end. Now, moving forward, we have the front end. This front end folder mostly contains the React website, as well as the socket calls for the data. And then we have the Pico code, which has all the code for all the sensors, as well as sending code to the MQTT broker. And then this last folder is Pico Senses, which includes our code that we use to test our sensors out when we were building it.
So our front end was built using React and it has a lot of additional functions. So first of all, it displays the live sensor data from the bat in real time. And there's also three different buttons. So the first button is turn head, which is just used to send a signal to the servo to turn the bat head. And there's a video of that.
Guess we'll just skip it.
Okay. Okay, so then our next button was the take photo button, which would take a photo using the camera, and the play sound button, which would get the MP3 file from the API, and it would basically be an audio file that would describe the image. And then lastly, we have a text box to send a message to the OLED in the watch, and that would be used so the operator can communicate with the agents. So some challenges we have was that our main challenge was that our battery slash voltage regulator was overheating, and when that happened, the Pico would just shut down, and we wouldn't have any of the sensors working. So that unfortunately did happen during the field of play. But besides that, a different challenge was that one of our temperature sensors did in fact melted. This was a one-time thing. We ended up fixing it and it worked fine. And our last challenge was that sometimes the Pico would just disconnect for like a couple seconds and then it would restart and it would continue working. So a bit annoying, but nothing too bad. So our gadget in the field test. So for the first the front end was able to successfully display the live sensor data, and we were able to send a message from the operator to inform the agents about muted audio. But then, unfortunately, the power did cut and the device stopped working. On the next slide, we'll have a video of what happened. Okay, so here we're sending the message about muted audio because we can't hear the agents. So we sent that and they do in fact receive the message and they were able to fix the problem. Yeah, that's basically it.
And then at that point, I'm pretty sure the data just stops updating and
Yeah.
everything broke. Oh,
So final reflections. What are some features we would have added if we had more time? Definitely would have left extra room for electronics, and we would have fixed the voltage regulator. And what did we learn from this experience? We learned the value of time and resource management, as well as prioritizing function before aesthetics.